So we will continue our discussion today on determination of molecular formula. For that we have already solved few problems. Let us continue to do that. In the first problem today in front of us, let us try. The question is, an organic, let me rewrite, an organic compound on analysis gave the following data. C is equal to 50 means carbon 57.82%, hydrogen is equal to 3.6%, and the rest is oxygen. Vapor density is given as 83. Find its empirical and molecular formula. So for the very first time, the vapor density has been introduced in front of us. And how to deal with it? We know that molecular mass is equal to 2 into vapor density. But before that, let us prepare the table that we used to do. And here, first of all, element, second is the percentage, third is the relative or number of moles, next is the simple ratio, then we will have number of moles, we should be writing atomic mass. So here we should be writing atomic mass. After atomic mass, there will be relative number of moles, then simple ratio, then we will have simplest whole number ratio, so this is the case. And under these circumstances, the elements are carbon, hydrogen and oxygen. So definitely, first of all, let us find out the oxygen percentage. Here we can calculate the oxygen will be like 100 minus 57.82 plus 3.6%. So we are getting as, so these two are the percentage of hydrogen and carbon. So obviously we are going to subtract that from the 100. So we are getting 38.56%. So let me put these values here. 57.82, here it is 3.6, and here it is 38.56. Atomic mass for this one is 12, 1 and 16. So here we are getting 57.82 by 12, 3.6 by 1, 38.56 by 16. As a result, we should obtain, if I rewrite this line a little bit on this side, 57.82 divided by 12, I will be getting this value as nearly is equal to 4.818, previously calculated by me. So I am getting as 4.818. 4.81. This is of course 3.6, no need to change. And the last one we are getting, previously calculated, once again it is 2.4. Now in order to get the simplest ratio, what we should be doing is, we should be doing 4.81 divided by 2.4, 3.6 by 2.4, and 2.4 by 2.4. Here it is 2, 1.5 and 1. So obviously 1.5 we will not consider. So in order to have the simplest ratio, we will multiply each of these by 2, understandable. So it will come out as this much. Now, after getting this, we can, if we are getting simplest whole number ratio, easily we are in a position to write down this one, empirical formula. So empirical formula from here we should write C4H3O2, which should be empirical formula. So empirical mass should be 4 into 12 plus 3 into 1 plus 2 into 60. So here it is 48 plus 3 plus 32. We calculated, so we are getting 4 into 12 plus 3 into 1 plus 2 into 6, we are getting 83. At the same point of time, we know molecular mass is equal to 2 into vapor density. So it should be 2 into 83. So we are getting 166. So now the value of N is molecular mass divided by empirical mass. So molecular mass, just a minute, molecular mass divided by empirical mass, here you can see. So as a result, we are getting this value as 2. When we are getting this value as 2, if we should be calculating the molecular formula, so the molecular formula is C4H3O2, the value of N should be written here, so it should be C8H6O4. So this is the answer that we were looking for. So let us move on. Let us move on to the next problem. First you write it down. The first time we have introduced this concept, vapor density and molecular mass. So we will be moving on to the next one. In the next one for today, the question is again a new type. New type process is same, but some of the concepts are new. Carefully see this one. Okay. Question is, it's a comparatively difficult one, I would say, harder, not difficult. A compound has the following composition. Compositions are: magnesium is equal to 9.76%, sulfur 13.01%, oxygen 26.01%, water 51.22%. Question is, what is its empirical formula? Interestingly, in this particular case, water is involved. Remember, in some of the compounds, we will have water of crystallization, means salt combines with n molecules of water. We must have seen copper sulfate. There we have seen 5 molecules of water. So it is that kind of case. So accordingly. Now, as our common process, we will make this chart. So element, we'll write it down. Element, percentage, atomic mass, number of moles. There it is, simple ratio and simplest ratio. So let me write down those. There it should be element, then we will have percentage, then we will have atomic mass, and then we will have number of moles, simple ratio, then we will have simplest ratio. Let us see how can we deal with this. So here, first of all, magnesium. Elements are magnesium, sulfur, oxygen. But then also there is water. Along with element, this is not element though. This is a particular molecule, but this is kept in same category. So let me write down the percentage: 9.76, 13.01, 26.01, 51.22. Atomic mass for magnesium is obviously 24. Sulfur, it is very well known, 32. Oxygen 16, and water is not atomic mass. So in this case, it is a molecule. So obviously molecular mass. But while calculating the number of moles, that concept will be applied. So it is 9.76 divided by 24, 13.01 divided by 32, 26.01 divided by 16, 51.22 divided by 18. Now, here is the case. Individually, it is to be calculated. For me, I have pre-calculated all the things so that we don't have to waste much time here in calculation. I hope all of you can do. I am getting this one as 0.40, 406 to be precise. This one, next one I am getting the same, 0.406. The third one I am getting is nearly equal to 1.62. And the fourth one I am getting as 2.84. As a result, what we can do is, in order to find out the simplest ratio, what we should do is 0.406 by 0.406 by 1.62 by 2.8 by, and we should be dividing all of them by the smallest number, that is 406. 0.406, 0.406 and 0.406. As a result, we are getting here as 7, here it is 4, 1 and 1. So the simplest ratio 1147. So what we should write? The empirical formula. It's absolutely different type. Check. MgS, magnesium 1 only, sulfur 1 only, 4 oxygen. So these two we will not write. Remember, there are 7 molecules. Remember, in case of water it is the number of molecules, but we should be writing comma because it is the water of crystallization, and that is why it is the special case. So today the problems that we have solved are relatively, the process is same, but it is of new type. Again, while water will be given, it has to be dealt with this way only. So this is very important. These two harder problems we need to solve.